good morning or day or night, whatever you have when you open this video. This is going to be the first video where you learn the really basics of Unity and the user interface, and we are actually going to make our first game. After you have installed Unity, you can create a new project. Uh, Make sure you have some rather new Unity editor version. Let's make a 2D built-in render pipeline, and let's put here our project name. It's gonna call Game of Balls. And Unity will create a Game of Balls folder under the games folder. So I have this. This is the parent folder for this all my game projects. And then when all these are good, then you can actually click this create project button. Okay, and now the empty project is open. So let's go through the user interface and see what is where, and then let's start to do the actual game. First of all, we have here hierarchy. This is the list of all the game objects and items and everything what we have in our scene. The scene tab here, it shows all the content. In this case, we only have the camera, and this is the camera kind of view. We also have a game window, so I recommend you take this game tab and you move it to the side like this. So I will a little bit customize this user interface. So the game view will actually show what the camera sees. So this scene is all the content and game is what the camera sees and what's happening in our game. Then we also have a project tab or project window, and then we have a assets folder, and inside the assets folder we have scenes folder, and we are gonna make some other folders and files in here. But as you know, this is the folder. This assets folder is the actual folder on your hard drive, and if you delete something in here, it's gonna be deleted on your hard drive. And if you add something there, it will be added in here. You also have a console, and this is really important for us. So I recommend you move it up there or to the side. So if we get any errors or messages or anything, we can see them here. And then also we have inspector, and if we click any object or anything, it will give us the information in inspector. And as you can see, it's the main camera. It has the transform information of the position, rotation, and the scale. And then also the camera has a camera component, and it has all the camera related information in here. And that's basically it. This is really the basics. And if we want to move or rotate, we have a move, rotate, and scale. Uh, we are going to use those in a few minutes. And otherwise, that's about it. Play button is when you want to play the game, you play it and then see what happens. Okay, good. So let's start making our new game, and I have planned for a game, and the game is gonna look something like this. Yes, this is a paint, and I'm gonna draw a awesome game in here. Um, let's make a game where we have this kind of a platform. Let it be a box, and we will have some walls on the left side, and then we have a wall on the right side. Then we will have a player, and the player will be a ball like this. And whenever we click our mouse button down, for example, in here, we will increase force. And we will increase the force as long as the mouse is pressed down. And when I release the mouse, it will see that what is going to be the vector from the mouse to the object, and it will launch the object, the ball, into this direction. If I hold my mouse in here, it will launch it into this direction. And if I hold it here, then it or release it in here, then it will shoot it that way. And then uh, we will put here platforms like a levels in here. So let's put it here, and maybe here, and maybe here, and maybe here. And the idea of this game is that this player will have, for example, health value 100. And every time we shoot the ball up, it will go up and it will go through these platforms. But when the first force is doesn't give enough force to go further up, the ball will start to come down. And we will actually record this position. And then the ball will come down, and when it hits this platform like this, we will actually calculate how high it dropped. So what was this distance? And based on this distance, we will decrease the health. So let's say the health decreased by 16 value. So the idea is to have this ball to jump so that the fall is as small as possible. So we don't get that much damage. And then we can jump up and down and we will try to reach some kind of end object that when we jump here, we will pass the level and everybody's happy. So now you're thinking, well, how about we just press the mouse button down and shoot directly from here to there? Well, we will actually add here some, let's put it like red. We will add here some obstacles. So we will add here some obstacles, and if the ball hits into these obstacles, it will take damage. So let's say it will take damage 20 or something. So that's the idea. So we have to actually try to go from here to here, here to here, here, and then try to reach the end of the level. And this is going to be a really interesting game. We will have quite a few features, and we will control the player, and we will handle the damage, and we will make all these obstacles and these platforms and everything, and we can go through them, and we will drop onto them, and we will move camera and so on. So this is going to be a pretty interesting game. So let's do it. We can do this. Okay. Okay. So let's close this one and let's start to make our actual level. First, um, let's create a new. I will actually make this in 3D objects, even though the game is 2D. We can make this in 3D objects, and maybe later we can convert this game into 2D graphics. But at the moment, we can use 3D objects. Let's make a cube, and let's call this as a base. And I will put this into position to Origo, and let's put X like, for example, 10. Okay, that's good. That's really good. And I also want to make a material for that. So I will create a folder. Let's put here materials. And I will create a new material because this is really dull, like a gray color. I want to be something different. So I'll right click, create and make a new material. This is going to be the base. And I will drag this base. You can actually put this material into this object for like, I don't know, three different ways. I can drag it to this object in the hierarchy. I can drag it in here, and I can also drag it when I have clicked this object under materials. There is the material, so I can also drag it here. So it's up to you, how do you want to do it. But in here, when we have this material, I will change the shader. If I change the color, you can see that if I put it, for example, green, or blue or red or anything, it's not that bright because this base material, the standard shader, it requires some lights, but because we don't have any lights, it looks a little bit like, well, not that bright. So what I'm gonna do is I'm going to change this shader to unlit to color. And when I change it to unlit, uh, no lighting can affect into this object. So now I have this color I want, and let's make it like, I don't know, maybe this light blue. Okay, that's good. Okay, that's it, and it's the base. Then let's go and do the walls. So 3D object cube. I'll name this left wall, and I want to make this. Actually, how you can move here, you can press your scroll button down, and with your scroll, you can scroll also zoom in and zoom out. So let's make this scale maybe 20. Is 20 good? 20 is quite good. And now we can move this into here. And I know that you're thinking that, okay, how can we put it exactly in that location? Of course, we could calculate x and y positions. This could be maybe something like minus 4.5, and this can be maybe 10.5, and it would be there, and that would be really nice. But if you don't want to do any calculations, and the location is something like that, you can actually press V button on your keyboard, and then take here and just move it there. So it snaps there, and now it's in the correct location. That's good. Then I can press another shortcut, Control D, which is duplicate. So I will duplicate this left wall like that, and I will rename this as a right wall. And then I will move it there. But because this X position of the left wall was minus 4.5, I think putting here 4.5 gives us the correct location in here. Okay, that's good. Then I will also make a new material. This is walls, and I will drag this walls material to those both walls. I will change the shader to unlit color, and then let's make it, I don't know, what's good color. Maybe a little bit greenish like this. Okay, that's good. Good. Then with the camera, I don't want my camera to zoom so close, so I will a little bit increase the size. So I click the camera, go and click size, and let's put here, for example, 8. That's good. I will also move my camera a little bit up. Now this says that in the game window it says full HD. This is the resolution it wants me to play it, or the aspect ratio I want I want to play. But in this case, I want just for development reasons, I will put here free aspect like this, and now you can see that I have this whole screen visible here, so it's looking quite good. Okay, let's keep it like this. Next, what we want is the ball. So let's right click, 3D object and sphere. Let's rename this player. And now when we see where is this located, so the X is minus something, yeah. Y is up there. Let's move it a little bit down here. But the Z value, this should be 0. Let's see actually all these others. Is the Z value 0? Yeah, good. I will also decrease the scale at 0 0.5, 0 0.5, 0 0.5, so we get a little bit smaller sphere. And then let's make a material. Create material. Let's put this player. and I will drag it there like this, and let's put the unlit and color, and let's create a color of something cool, maybe orange like that, so we can clearly see where the ball is. Good. So now if I press play, nothing should happen because what I have done is I have put here just the balls and the sphere, and if I press play, nothing happens. Yeah, nothing happens. Actually, I will change this play maximize to play focused so I can see the Unity user interface while I play. So, but nothing still happens. What I can do is when I click the sphere or the player, we can see that it has few components. There is mesh renderer, which related to what it looks like, and then we have a sphere collider. So the sphere has a collider, how it collides to other objects. So if I add here a rigid body, I will put here a rigid body component like this. The rigid body is a physics engine kind of where we give the object a mass and all other information. And also the gravity will affect this ball right now. So if I now go and press play, the ball should drop on the base. Okay, this is good. So now we actually have some physics in here and everything works. Next, what we're going to do is we are going to make a script. We are going to make a script and we want to do some things for this ball. So you probably have installed the Visual Studio with Unity, and I right click and create and make a folder called scripts. And then I go inside the script folder and I will right click and create first script. It's going to be actually a component. So all our scripts, so let's make a C# script. Let's rename this as player control. So this script, it's going to be a component for this sphere. So this is going to be custom thing in here. So if I drag this player control on this object, I can actually do it many ways. I can click and drag it here. I can drag it here. I can drag it here. And I can also click this add component and type player control. And you can see that there is player control. So either way, it's up to you how you do it, but we get our custom player control component in here. Well, it doesn't have any code yet, so I will double click it and open Visual Studio, and then let's see what's in there. Okay. If everything went smoothly, you should now have Visual Studio open. As you can see, we still have Unity in here, and we have Visual Studio, and the player control um, script is open. Uh, you might know basics of programming. So this is the class. It inherits mono behavior, which gives us all great things for our script. There's two functions. The first function is start, which means that it actually says here that it's called before the first frame update. So what happens? It runs this once, and then it runs this update once per frame, which means that if your game runs, for example, 60 frames per second, this update will be run 60 times per second. Okay, that's good. There's other functions also. We are going to make our own functions and everything, but for now, these are the things are here for now. Let's make a first variable. So I will put here public float force. What this means, it means that this force variable, it's going to be float, and it's going to be public. What this public means is that in Unity, so if I save this Control uh, S and you go back to Unity, the public word means that if I go check the player, we can see the force variable in here. If you want to be a professional programmer, you don't necessarily put every variable as public. If you wanna make it private, you may wanna put it like mm, you can put here, because if it's private, you can't see it inside the inspector. Uh, but we can put here like a serialized field. So if I put here serialized field and it's private and I save now, it should still be here. Yeah. But if I remove this serialized field, it's gone. It can't get it here. Yeah, as you can see. But for now, you can either put here a serialized field or you can make this public. It's up to you for now. This is really the basic stuff. Okay, that's it. And next, what we want to do is we want to put here in the update. Let's try first increase the force. So if I'll type here like if uh, input dot get mouse button. What this mean? And I put here 0. This means that if I keep my primary mouse button down, something will happen. So what will happen is I will actually put here force plus plus. And when I save and when I go back to my game and I press play, and when I click here on this game screen, there should be, as you can see, this increases. As long as my mouse is down, it increases. And what happens is that because it increases every frame update, so when I hold my mouse button down, every frame it will increase. And if you calculate, you can see that the frame rate is something like maybe 2 or 300, because there's 2 or 300 increase per second. Okay, uh, that's the idea of this. But there is a problem of increasing force based on the update. Because, for example, if I have a really fast computer and my force is increasing 300 per second, and then somebody else who's playing this game has a really slow computer and the force is increasing, for example, 20, 20 per second, then the game will actually work really differently for both of our computers. So, uh, in a worst case, for example, if some game has, for example, a movement or something based on the frame rate, it would be really odd situation that the people who has faster computer, the player would walk faster or something. So how do we fix this? We're gonna fix this by not putting force plus plus. I will actually put here force plus equal 20 times time dot delta time. What this means is that I will calculate the delta time. It will gives the interval in seconds from the last frame to the current one, which means that if I have a lower frame rate, this value will be bigger. If I have a high frame rate, this value will be lower because it's the interval in seconds. So what I mean here is that it doesn't matter how often my update is calculated or run, my force will increase at the same speed on slow machines and on fast machines. So this is the way you kind of take care of the increase of value for this force on all computers. So now when I press play and I go here, you can see that it increases. It increases a little bit slower, but then did I save? I didn't save. Okay, it didn't actually go slower yet. It should go now a little bit slower. Let's see. Yep, it goes a little bit slower, and but now it goes the same speed on all computers. This is good. Okay, let's go back to our code. So now we have an update, and then we have this if we press the button, it will increase the force. Let's put here a little bit more variables. I will put here public rigid body. Let's put here, for example, player RB, which is the player rigid body. And then also let's put here public float health. And well, that's good for now. If I save this, what happens is that now I can see those two new variables in here. Why do we need this rigid body here? It's because when we release the mouse button, I will put here soon an if statement about the releasing the mouse button. We want to call this rigid body component that's attached to this game object and tell this rigid body that we are getting the force to this direction, to up direction. And that's what we want to do next. So how do we get the rigid body component on this script? Because the rigid body component is this component here, and we want to get access to this. So what I can do is I can actually just drag this rigid body component in here, and then it will be kind of the value of this variable will be this component. So now whenever I call in this script, I call player RB, I will actually call the rigid body of this object. So let's put here if input dot get mouse button up 0. So if I release the mouse button, then I could call the player RB dot, and there is add force. And now with the add force, it asks that where is the force? What is the force direction? There's a vector tree, and the vector tree is three-dimensional. Well, it's a vector of three values, x, y, and z. So we can point it to any direction. And I will just put here like vector3.up. This vector3.up, it's the same as vector3 0, 1, 0. So it's actually one unit long vector pointing up because this is x, y, z. Then also we have here force mode. I will put here force mode dot impulse like this. And then I will, because it reads vector up, I will also multiply this by the force. Have you noticed that when I type something, for example, game object or something, you should get this IntelliSense, this drop down, which says game object, and so on. If it doesn't give you this information, then you have to go into Unity in here and go and edit preferences, external tools, and choose your Visual Studio version in here. You probably have open by file extension. Don't leave it like that. Choose Visual Studio or something, and then close the Unity and Visual Studio, open your project again, and then it should work. If it doesn't work, then just, I don't know, call me and I'll try to help you. Okay. Okay. But that sometimes that happens, but it should fix it. Okay. So now get mouse button up. It multiplies it by force. It shoots it up. It's the first mode is impulse. Let's save this and let's try this out. Yep. Good. And now the game is running. I will go and click, and you can see that the force is increasing. Oh, it went pretty because it was 53. It went really high. Hopefully it's coming back down. Maybe. Yeah, there it came down. Okay. But you can, oh, because we don't reset the value, it goes every time, it goes faster and faster or with higher force. So uh, let's put force as 0. So now it will reset the force every time we launch. So now you can see that if I jump, yeah, it will reset the force, and now we have much better control. That's good. Good. Okay. To make things a little bit more clear, I would like to put here, make this shooting as a function. So I will put here like void launch, and then I will put all these inside the launch like this. And when I increase this value, this force value, and I release my button, I will call the force. I will just call the. Oh no 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 not force. I will call the launch function like this. And because the force variable, we can actually put here the force as a parameter, and this launch function will accept force amount, and then I will put here force amount like this. So I will actually pass the force from here to here and then to here. It will work with just the force because this variable is this whole class, but this is actually a good way to work, I think. Okay, but there's no change. This should work. If I save and go and try to play it, it should still work. So every time I release my mouse, it will run the launch uh, function. Okay, it works. But now our ball goes up and down. So next what we do is we're gonna try to make it to go left and right. And for that, we're going to need a little bit uh, interesting methods, I would say. So if we think about our game is actually 3D. So this whole scene is 3D. We have a button here which is 2D, but if I click this one, you can see that the whole game is actually 3D. It's in a huge, endless, infinite 3D world. And you can see that the sphere is here, and we have the walls are over here, and the base is here. So our objects, they live in a three-dimensional world or three-dimensional coordinate system. But our cursor, the mouse cursor, it lives here in the game. It has a 2D uh, coordinate system. it doesn't sense any 3D in here because it's kind of knows only the screen space here. So somehow we should be able to see the location of this mouse based on this sphere's location. So we should know that what's the direction of these two or how they are located. So what we do is we go to our code and we try to kind of put our mouse position to the 3D environment. So I will put here like a vector3 mouse pos equals, and we have this kind of method here, camera.main dot, and then we have this screen to world point. So we will take our mouse position and we will put it from the screen to world point. And it will ask that what's the position. So it's going to be the input dot mouse position. So how would I say that this will move or transform mouse position from screen location to 3D world location. So what can I do is I can in here I can put debug.log and mouse pos. So if I do this, whenever I release my mouse button, it will do this magic, and then it will put to the console the mouse position. So let's see. So this is the mouse position. As you can see, when I move it right, the X will increase. When I move it up, the Y will increase, but the Z will always be minus 10. Why the Z is minus 10? It's because our main camera is located in minus 10. Because even though I'm clicking here, it doesn't recognize the depth, the Z value, so that's why it's minus 10. So that's our mouse position. So what we want to do is, because we want our mouse to be in the same depth in the Z value that what we have for our ball, I will actually put here that our mouse position dot Z equals 0. So that's going to be the value for the Z value. And then the direction um, from the mouse to the ball or the player is calculated using b minus a vector locations. So what I'm going to do is the direction. So let's make a vector3 direction dir equals mouse pos minus transform.position. So what this does is that it's actually takes one position, let's let it be B, and then it will take the sphere location, which is going to be the A, and this is going to be the direction of the vector from our sphere to our mouse position. And then also we will put here like a normalist, because this is going to be vector3, and the length of this direction or this vector is if I put my mouse here, the length of the vector will be like this long. If I put it here, it's going to be this long. But if I have like I can put the mouse, we don't actually know where our mouse is put. So this normalized will be actually, it returns this vector with the magnitude of 1. So it will actually cut always the vectors so that this is magnitude of 1, magnitude of 1, magnitude of 1, magnitude of 1. So whenever, it doesn't matter what direction the vector is going, the length of the vector will be 1. So that's what we want to work with, this kind of vector. Okay, and now when we know the direction, we can actually tell the direction to this launch function. And now we can go into here and I can put here vector3. Let's put here direction. Let's put here like, well, let's like force direction, because force direction, let's put here like this. Okay, force direction, it's the direction we want to put the force. If we already have the force amount, this vector up is the upwards pointing vector. Well, you can see that the force direction is the vector 3. This is vector 3. How about we put here just force direction times force amount, and let's see what happens. Okay, let's save this. And let's go back here. Okay, there was something like that. Okay, what happens now? If I keep my mouse up here, it will actually bounce there. If I keep it here, it will bounce there. If I keep my mouse button down here, it doesn't work because it tries to go towards my mouse. So when I put it up here, it goes towards my mouse. It wants to go down if I keep it here. So what we want to do is that if the direction y is negative, then we want to multiply it with -1 for the whole vector. So I will actually put here like if direction dot y is smaller than 0, then we will actually multiply this dir with equals minus 1. So now it will actually flips the direction of the vector, or the direction vector. So now when I move my mouse here, it should go that way. So let's see. Yep, it goes that way. So now I can try to hold it in there like this. Okay, that works. Yep, good, good. Yeah, perfect. Yeah, that's how it's supposed to work. I will actually go back to my 2D view so I can see it from here. Okay, good. So now we actually have a really nice control feature for our object, and that actually works pretty nice. And let's see what we have here in the launch. We can actually change the color when we launch the object. Let's change the color a little bit. So let's put here like we can actually call get component. This get component is a command how we get some component from this game object. So get component, let's call renderer component, and we can call material color equals color dot, for example, white. So what happens now is that when I go to test this, whenever I shoot up, or when I shoot, it will change white. Okay, it works. So this is really simple way to test that, okay, this code works and it can change the color. Okay. Okay, that's good. It's working. Next, let's do the platforms. So I'm going to right click, create here let's make it cube, and let's name this like a platform. Platform. Oh my god, there are so many typos. Okay, like that. And let's make this to locate Origo, and I will move it up a little bit. Okay. Let's make the Y scale 0.2, maybe 0.1, better. And then X will be 10. Okay, that looks good. And then I will make a material for that. Okay, let's drag it there. And let's change this shader. And let's make the color. What is good color? Oh, that's good. Nice. Nice color. Good. So what happens now is that because the platform is here and it's kind of blocking the sphere. So if I should shoot up, it should hit kind of to the ceiling. So it stops. Okay. How do we prevent that? So we want this ball to go through when it goes up, but when it's coming down, we want this to drop on the platform. And for that, we are going to need a script. So let's make a new script called platform. And let's add this platform script to the platform. Yeah, like that. And then also what we need is we are going to need for this platform a layer. We have here for the platform two different kind of things. There's layers and there is tags. Actually, we also need the platform a tag. So let's first put this tag. So I will put the add tag, click the plus sign, and let's rename it platform. Let's save it and let's tag it as a platform. That's good. And then for the layer, let's make two layers. First layer, or the layer number 6, will be platform inactive, and the other one will be platform active. Okay. So when the platform is not active, it's going to be on the inactive layer, and when it's active, it's going to be on active layer. So first, when our game starts, the platform will be on the inactive layer, like this. And now this doesn't change anything yet, but when we go to edit and project settings, and I go here and change, where is it, physics, and in here we can see that there's the platform inactive. And when I take this check mark from the default and from the platform inactive, when I take this away, then the default and platform inactive won't collide together. So because the player is on the default layer and this is on the inactive layer, when I play this, now we should see it goes through. This is amazing. Amazing, amazing thing. They kind of don't see each other. So what we do now, because we have a script, well, we have to open the script like this, because we have a script for the platform. We are going to check every frame if the player is higher than this game object, then change this game object layer to active layer. Okay. So what we are going to do is we are going to need a reference to the player. So let's put here public game object player. This is our player on the scene. And I would like to tag this player because we have the player here. I can tag it as player. So I can easily get the reference for this player because in the start, when the game starts, I can put here that player equals game object, find game object with tag. You can see there is find game objects and find game object. So take it without the S. So we just want to find one object. And then we put here like player. And now the platform will have a proper reference to the player object. And then we are going to make the check. So every frame we will check that if transfer.position is the transfer.position.y, so if the y location of the platform is smaller than player.transform.position.y, if this happens, then we will change the layer and the color of the platform. So let's go here and put game object.layer equals, and we can put here layer mask dot name to layer and put here platform active. Let's see what it, how did we type it? Platform active. Yeah, that's good. Yeah, platform active. Also, let's change game object. So change the platform. Actually, we don't need to type game object. Let's just put here get component renderer dot material dot color equals color dot, I don't know, cyan, for example. So now what happens, hopefully, when we save this and when I go here and when I jump up, you see everything goes really smoothly. It changes the color, it changes everything, and now we can stay there. That's pretty good. Let's see if I try once more. Yeah, good. I try to see if I. This is actually a fun thing to do. Okay, yeah. Let me try once more. I try to see if there is a bug in this. If I go really close, yeah. Did you see it? Did you see what happened? Okay, I try to do it once more. You see how it actually bounces, kind of bounces through it. Yeah. What happens in here is actually we need to understand how Unity works and how these locations work. Because these objects, they have the colliders, but they don't recognize each other's until the sphere is higher than the platform. So if we zoom really close, I will delete this amazing picture. If we zoom really close, this is the platform. This is the platform, and the platform has its location in here. And then we have the sphere, and the sphere is like this. And the sphere location is here. in the frame when this position is higher than this, so when this position is here and the sphere is like this, it recognizes that it's higher, so it will activate this platform. And when it activates this platform, it will actually make these colliders, this collider here, and the platforms collider to hit each other. So what happens? It will, because Unity doesn't allow the colliders to be inside each other. It will actually put the sphere here, and it's going to snap or pop from this location into here. So what we actually need to do is that instead of saying here that the transfer.position.y is smaller than the player.transfer.position.y, we should put some calculations in here. So it should be this location. So we have to minus from this location half of the platform and the radius of the sphere. So what I will put here is I will put here minus transform.local scale local scale dot y, because that's going to be the scale, minus player dot transform dot local scale dot y divided by 2. So half of the sphere and the local scale of this. So now what we have here now, it shouldn't happen this popping anymore. And this is something really important to know when you make a game, is that you there might be some really weird feature that you can see that it doesn't work, it doesn't pop that way. So it's important to understand how the game engine works under the hood. I'm trying to test. Yeah, you can see it. It doesn't do it. Yeah, it works really good. So now it's working. Everything is good. Everybody's happy. Okay, good. Next thing about our game is making a prefab. So I'm going to make a folder called prefabs, and I want to make a prefab from this platform. And prefab is like a blueprint of an object, I would say. So so if I want to make several platforms, I want them to be all the same. And I don't just want to copy it here. I want to make a prefab. So if I want to change all the platforms, I can just change the prefab, and all the platforms will change based on my modifications. So I will drag this platform from here into the prefabs folder, and you can see that it turned into a blue one. So now if I take a new platform, I can just drag it here to the hierarchy and then move it up. I drag and move it up. So this is the way I can easily design my level and make new objects here. And if I want to change the color or the size or whatever, I can just double click the platform, go to this prefab editing system, and then continue from there. Good. Okay. Now I can try this. So when I play, okay, a little bit more force. Works, works. So this actually works. Good. Great. Great stuff. Okay. So what we are gonna do next is we wanna put there the health system. So let's go here and let's start to write some code. What I want to do here is I will actually for just for debugging our game, I will put here like a private void on GUI like this. So on graphical user interface. So this is a function that will be it will run basically every frame, and I can put here some labels to on screen to show some values. So this is just for debugging. So let's put here good dot label new label, oh no, new rect, and then we can put here location. Let's put there 10, 10. Let's put here 200. This is the width, and then the height 20. And then let's write here force, and then let's put here force. Okay, does it work? It doesn't. What did I miss? Force. Force doesn't exist. Oh, we are in the platform. Yeah, see, I'm in the wrong script. Let's cut this. Let's go back to the player control. Okay, in here. Okay, and when it's here, then we can now test it out. So let's save this. Control S. And let's save this both. Yeah, and then let's try to play. When I press play, it should show me the force in here. Yeah, and when I increase it, you can see that okay, that actually works. Yeah, okay. If you want to change this color or this size of this text here, you can actually put here. Is it like Blico style? I think it's yeah. Let's put here my style. Yeah, let's put here like this. GUI style, my style, and then maybe in the start, let's try my style dot normal. Let's here normal dot text color equals color dot red. If I want to put it red, and then my style dot text no font size. Yeah, font size equals 16. Okay, let's try it now. Now it's probably red and a little bit bigger. Oh, no, no, it's not because I have to, of course, apply this my style into here, in here. My style. Yeah, of course. Yeah. Let's try it again. Okay, now it's red. Well, the red is not that good color. I will put it back to white, but you get the idea. Yeah. Okay. Good. Okay. Well, what we want to do is I want to make we have the force when we want to do some other variables. So we have here the health. We want to put here public float high point. This is going to be the high point of the kind of the jump. We want to know is the ball going down? So that's what we want to know. And then we wanna give it some damage like this. Okay, that's good. And then let's save this, and let's go and put these values also in here so we can see it. So I will duplicate this line, and I will put here because this is 20. I can put here 30, 50, and 70, and I will put here like high point, and here I will put going down, and here I will put damage, and we also need the health value. Let's put it health, and let's put here 90. And now let's change these. This is the high point, going down, damage, and health, like that. Good, that's really great. Let's Control S, let's save this, and I think it should work. It should work now. It displays us a little bit information. Does it? Yes, it does. But only the forest works at the moment. Let's put here for our player. Let's put here because now we have all the values here. Let's put here the health is 100 in the beginning. And we have the high point going down, damage. These are really important for us. So so we can we can work with those. Okay. Okay. Let's go back to our code. And we have here, where's the update? There is update, and we can go just after the get mouse button up. We will start to write a little bit information in here. Let's check every frame when the ball starts to come down. So let's check it out. And how we do it. We are going to, when we are going to shooting it up, when we launch the object up, we will say that going down is false because we know that we are going to shoot it up. We will tell that the going down is false. So we will check from the rigid body that if player rigid body dot velocity dot y is smaller than 0 and going down equals false, then we know that this is the moment the ball is this is the moment or frame the ball is starting to come down, and then we can tell that going down equals true because it previous frame the velocity dot y which will be positive, it will be positive until it getting down, and the going down is false as long as we first time it's going negative, then we will tell that the going down will be true, so it won't run this if anymore because the going down will be true from now on. Okay, so this is good. We can also change the color. So let's put here like a get component renderer material dot color equals color dot red. So you can see that it should work. It should change the ball red when it starts to come down. Yep. And when yep. Why it doesn't go white? Yeah, because oh, that's interesting. Why the going down is always true, even though we put it false. It's probably because the launch it's going down on false. Well, let's see. False, going down true. Maybe it's somehow. Oh, yes. Now I know. Yeah, because what happens in here, actually we can check it out if we put here like this, and let's velocity y. Let's put here like player rb velocity dot y like this. So we can see, let's see if we check, it goes white, now it's red. See it, even though it's yep, like this, it's not zero, it's like really small value. And when I shoot it up, it recognizes in the when I release my mouse, it will recognize that this is below than zero, even though it's really small value, and it's going to go through this in here and keep it as red. So instead of making this, it's just rounding error or something like that, I will put it smaller than minus 0.01 like this. So now it it it, it doesn't matter this, hold on, this small value. So let's try again. We have to have some threshold for it. So now it works. Okay. Yep, it works perfectly. Yeah, that was the reason for that. So when it's coming down, we want to record the high point. So we want to put here like high point equals transform.position.y. Okay, and then because we know the high point, then we need to check the collision. Let's just above this launch. Well, actually, let's put it under the launch because the launch is there. Let's just above the on GUI. Let's put here function that's basically built in for our game and for the Unity. It's a on collision enter. So what is this? This function is that whenever this game object, this player, will hit something, this on collision enter will be run. And whatever the object hits, this collision is the object that's it's hitting. So what I mean that if the sphere hits a wall, this collision object is the wall. If the sphere hits the platform, this is the platform. So what I'm going to do is I'm going to check the tag of the collision object. So then I know that what I'm hitting, because I don't know, this is run every time it hits something. So if collision dot game object dot compare tag, I will compare the tag that is the one we are hitting. Is it platform? So we are checking that is it the platform, because all these platforms has a tag platform. I'm checking that do we hit an object called platform. If we do, we can put like dev.log hit a platform. Okay, so what we want to do is we wanna let's take some damage. Oh my god, that's great. What we want to do, we want to check if going down equals true. Only if the going down is true, so if we are coming down, we want to take the damage. We don't want to take damage if we are going up. So if the going down is true, then we want to calculate the damage. And if you do a free falling somewhere, the higher you come, the heavier you will hit, because the gravity is like it's accelerating you more and more. So I will actually put here like damage equals math f square root uh, 2 like the 2 times, and then I will actually fetch the gravity from the unity's physics. So we have here project settings, we have here physics, and we have here minus 9.81, which is equals the gravity on Earth. And uh, I will do it this because we can put here like a physics dot gravity dot y, but because this physics dot gravity dot y is negative number, and because we have a square root here, having something negative number inside square root is not a good thing. So what we are going to do is we are going to take the positive value of the gravity. So I will put here like a math f dot absolute value of the physics of gravity like this. And then I will multiply this with uh, with uh, with the high point minus transform dot position dot y, and like this. What's wrong? And I will also, because this is a multiplication, it's multiplied by this. I will put here also math f dot abs absolute value of this. Does this help? It doesn't help. For what reason? This is what does it say? Something's expected, and the something what's expected is this is here. Open, open, close, close. Oh, there is one too much. Okay, that's the reason. Good. Oh, okay. So then when this is done, then we wanna make here avoid take damage. We wanna make take damage this function, and we wanna take as a parameter float the damage taken, and let's put here like health minus equal damage taken. So now we will decrease the health with the damage. And if the health is below than 0, then we will do the die function. Well, actually we don't have the die function, so let's put here what die, and then you will as well something happens here. Okay. So we will decrease the health, and then we will just call the take damage with the damage value. So damage, that's good. Take damage. Okay, that's good. Okay, so I think that's looks good. So let's press Ctrl S, and let's put here. Let's try it. Yep, everything is good. So I will jump here and let's see what happens to our health value. Oh, nothing happens yet. Yeah, I jump. Every time I jump here, I will lose some health, as you can see. And the higher I jump, the more I will lose the health. Yeah, that's good. That's good. That's really good. It will calculate all the velocities. It will calculate the damage. The going down, true or false, it works. high point, it recognizes every time the new high point, and the health. Well, health is now negative. So what we want to do is we wanna, if we die, we want to actually let's put here public vector tree uh, or start position like this, and we want to save the start position equals transfer dot position. So in the start we want to be there. So when we die, when the die function, we want to move this. Something happens here, so we want to move player back to the start position, which is the beginning. So transfer dot position equals start position. Okay. So now actually I will decrease my health value a little bit because it just doesn't take that long to test. So health is 10. Like this. And it's here. Good. But now I have a problem, as you can see, that I can't go through this anymore because I have this is my second try, and then there's a problem going through these platforms. So we have to do something for those two. Okay. So what we do is in the die, we put it back there. We put here like health equals 100. We want to put the health back to 100. We want to player rp dot velocity equals vector 3 dot 0. So we will stop all the movements, all this movement of the player, and then let's go through all the platforms. Well, let's take all platforms to an array and go through them with for each and change their uh, this color and layer to inactive. Okay, let's do it. So that's your job. You can now stop this if you want to try it by yourself. But what we're going to do is we are going to make a game object array of all, let's put here, all platforms equals game object find game objects with tag. So we will actually use this platforms because this will return an array, and it will return an array of game objects, and it will put them into this array. So what I'm gonna do is I'm going to for each going through. So let's put here game object single platform in all platforms. So I will go through all the single platforms, and then let's put here single platform dot layer equals layer mask dot name to layer platform inactive. We can also change this single platform dot layer dot get game of no single platform dot get component renderer dot material dot color equals color dot, let's put here like white. So you can see if we go through this, let's try it. Did it work? Yep. Okay, let's play it. Yeah, I changed everything. Yeah, we don't want to do change everything. But this is we can divide this. Well, it was magenta. Let's put it that way. Yeah. No, it's good. Not white. Let's just put it magenta. Okay. Or we don't actually need to change the color because we can actually we have done it before. So we well let's just put this in the comments. So like that. Because actually we have pretty good way. If we don't change it, if we could change all, but we don't have to change it because with these platforms we can see that how far we were last time. So this is actually good this way. Yeah, yeah, yeah. That's good. Yeah, it works. Okay, that's a great feature. Really good feature. So now we can try it as many times as we want. Next thing is let's and maybe the final thing for this video is let's make the platform. So no, not platform, the obstacle. So let's right click. Let's put here 3D object and cube, and let's rename this obstacle. And I will create a material for this. Let's create material obstacle like this. I will drag this to the obstacle. I will change it to unlit and color, and then I will make it red, dangerous red, and I will also tag it to as an obstacle like this. And then what else do we want? Maybe nothing much. That's good. Okay, that's our obstacle. And then we will write a little bit code to this player control because we know here that if we hit platform it will calculate some damage, but if here's the if like this, let's clean it up a little bit. Okay, but if we collision dot game object dot compare tag obstacle, what happens then? We want to take damage like 20 for example. So now it should happen. This was a really simple feature. If I go here, I go here. If I put this here, and now I jump to this, like this, we have, oh, well, of course, it killed it in the first one, but yeah, 20, 20 goes, so 60, 80, 60, 40, 20, and now it's again like that. Yeah, good. So it works really great. I will put this my health back to 100, and then with this obstacle, I will make this obstacle as a prefab. So let's put it here. And now, if you want, you can make these obstacles with a scale. You can make different one. I will actually use shortcuts W, E, and R. So I will put it like this. I will put this. I can actually put here new obstacle. I will stretch it like this, rotate it. Okay, that's good. And then obstacle here, and like this. So this way we can kind of try to make player from here to there and so on. Maybe I'll move this a little bit there and maybe this a little bit there. So we have there a pathway to there, and then obstacle here, and then we will like this. Okay. So now we have a game where we have to try to like go like this. Oh my god, I hit there. I hit there, or I hit there, and then I hit there. So I get damage from here, and then I get damage from there, and now I'm here, so I have to jump here. Oh, I died. Okay, too difficult for me. Okay, but as you can see, you can make the game you like. Oh, let's see. Okay, it works. Okay, I got through it. I still have 28 8 health left. But let's make the camera to follow this sphere because it's we don't want to be stationary. We want the camera to follow the player. So let's make a new script. Let's put here C# script. Let's put here camera control like this. Let's put this camera control to the main camera. Oh, let's wait a second. Okay, camera control like this. That's good. And then I will actually let's open it here. And we need just a few variables. Let's put here a public transform target, and then also public float smooth time. Yeah, let's equals 0.2, and then also uh, private vector tree velocity equals vector tree 0. This is actually taken from Unity's documentation about from the smooth damp. Yeah. So let's put here like a target equals game object dot find game objects with tag. So this we want to be the player dot transform. The transform is the transform component that includes the position, the rotation, and the scale. And then we want to put here like vector tree target position equals target dot. Oh, there is a transform point, new vector tree 0, 0, minus 10. Okay, let's try this, and then we want to do this smooth movement. So let's put here like transform dot position equals vector tree that smooth damp transform dot position target position ref velocity smooth smooth time. So if it works, I can change this smooth time to behave it a little bit differently, but let's try this. So I will put it here. Let's see. Let's play. Okay, seems good. Yeah, this is pretty good. It follows it. Yep, good. And maybe I will fix this to fix fixed update, so it updates it like every 50 or 60 times per second. Maybe it becomes a little bit more smooth. Let's see. Yeah, it's smoother. It's a little bit better. Yeah, it's beautiful. Yeah, it's really good. Good. Really good. Okay. And if I put this like 1 second, we can test it out. Then it's going to be much slower. It's not. Maybe it is. Okay. Okay, but that's it. That's good. So now we have here We have our obstacles. We have everything here. Uh, we have our camera, and that's for it now. Let's continue here if you're interested. And it's this far. This is amazing. There's a lot of new things we can add here, but this is really the basics of Unity and really the basics of this game. And from here you can continue to do all kind of features. Yeah, thanks for watching.